Buddy, how are we doing today? The day was coming. I told you we are having. Notice our notes are slightly different format. I am actually still for this using Math Excel, our old program, because they have better questions. And what we're doing today, this comes from section 7.3, chapter 7, section 3, and 7.4. So it's the multiplying exponents and it's the power-to-power rule for exponents. But in this case, it's also dealing with scientific notation, because if we look, scientific notation like this here has an exponent. And I can already tell some of you are like, oh my gosh, Mr. C, why are there so many words in these problems? Yeah, because this has to do with some stuff where real life starts to take place inside of the scientific notation. And that includes all of the exponents that we're using for it. Over here, we have our little diagram. This is Mr. Scientific Notation Man. All right, so his arms represent, like, if we have to move decimals. Okay, so if we have to move a decimal to the left or to the right, we have to do certain things with the exponent. So if we have to move a decimal to the left, the exponent has to increase for every time it moves to the left. If it has to move to the right, well, then it has to decrease. So we have to be very, very careful with that, okay, as we start to look at this. Because we have placement when it comes to scientific notation. Notice I'm going to highlight this particular, we're not doing the problem yet, but I'm using this as an example so we can know what proper scientific notation looks like. Proper scientific notation. I can get my highlighter to work. And of course, nothing wants to cooperate, but that's the way it is sometimes. We roll with the punches and we make it work. Okay, there's that back. That line is too thick. All right, anyway. So if we're writing with this here, we look at how this scientific notation looks. Okay, we're dealing with something in particular here. So we have this, what, the place value that it holds, we are only allowed to have one place value in front of the decimal. Only one. So this place value has to be greater than 1, but less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Anytime this decimal moves over, that is not proper scientific notation. It is no longer accurate. So we only deal with the scientific notation in the ones position. Never do we have a number more than the ones when we're dealing with scientific notation. If it is more than 1 or less than 1, then we have to alter that decimal point. So if we move it to the right 1, we increase the exponent by 1. If we have to move it to the left 1, then we have to decrease. And that's what Mr. Scientific Notation Man over here does for us. It allows us to look at a nice visual on where is this thing moving, because I always have to look this up every year and make sure that I'm moving my decimal to the right spot before I teach it, because it isn't something that we use very often. You use it more in math class, in chemistry, physics, things like that. Okay. What we're going to do is, now I know we have these in order, but I am going to try and figure out about setting these up. The first problem is probably the easiest, even though it looks a lot harder. First thing, we have to read it carefully. Okay, so it says one of the brightest stars in the sky is Capella, which is part of the constellation, however you pronounce this. Okay, they give us sometimes words in these word problems that maybe we don't know what they are, or we can't pronounce it Argua. I mean, I don't know. I'm not a astronomer, so I'm not good with stars and names and constellations. But I have this star. We'll call it Capella, which is part of the constellation Argua, or whatever it is. Make up your own thing. Capella is 45 light years from the Earth. And then it tells us 1 light year is 5.88 times 10 to the 12th. I want you guys to realize something here, okay? I'm not sure what's going on with my highlighter today. All right, well, we're just going to have to do without the highlighter for today's lesson. So we have to realize that this is 5.88 times, and the base for all of these is the times 10. So this part here is the base. We're looking at the times 10 is the base. This is the part that in all of our rules, remember we say the base stays the same. The times 10 does not change. There's actually a little key. If you ever have to input this, there's a little key for the X. It's not X on the keyboard. It's a special multiplication X. That special key, 10, and then you raise it to a power. Okay? And basically what this is saying is that if we were to take this and write this out, we would have to take this decimal point here and move this decimal point 12 places to get our number. So we're dealing with some really, really big numbers here. We do not want to have to do math with that. So what we do is we have the scientific notation that we reduce it to so that this ends up being much better. Okay? So now as we look at this, we're going to do what we think. Let's, again, read it one more time. So we have this star that's in a part of a constellation. This entire thing is not useful information for us, but whatever, it's there to build the picture. This star is 45 light years from the Earth, and they say 1 light year is equal to this amount. So how far is it in miles from the Earth? Okay, so if this is what a light year is in miles, and we know it's 45 miles, we need to be able to take this number and multiply it by 45. So to set up the problem, we're taking 45 times 5.88 times 10 to the 12th power. Now look, in honesty, are we really dealing with any kind of multiplication of exponents here? 45 has no exponent. There's no power to a power or anything like that. So we're basically, all we have to do is we have to take the coefficient, which is the 5.88, and multiply it by 45. And guess what? This is definitely calculator stuff here, because I'm not dealing with all these decimal points. So you have 45 times 5.88. And we get 264.6. 264.6 times 10, because this, remember, this is our base. This is the base, times 10 to the 12th power. Now, what I said before about how this here is proper scientific notation, there's only the one spot is filled. Ooh, look at this. Do we have more than the one spot? Yeah, we have stuff bigger than one. This is actually the ones, the tens, it goes into the hundreds. So we are going to have to move something, okay? We have to move something. I'm going to change color on me. So we do have to move this. This has to move 1, 2, We're moving it 2 spots to the left. So if we look at Mr. Scientific Notation Man here, when we move this decimal spot, put that there. There's your decimal spot. When we move the decimal spot to the left 2 places, that means our exponent is going to increase 2 places. So in order to finish this off, we have to just rewrite it one last time, and you have to read the directions, okay? It says what? Simplify your answer, use scientific notation. It says do not round. That's important. Do not round your answer. So we end up right here with 2 points, 6, 4, 6 times 10, and 12 plus 2 is 14. And that's all that we have to do for that particular one. Multiply the coefficient, distribute that 45 to the coefficient. Then we have to say, hey, this is not in proper scientific notation. I have to move the decimal spot 2 places. Because we move it to the left 2 places, the exponent has to increase 2. All right, so let's try this next one. And as they go, you know, they may try our patience in some of these, but we have to just do our best, okay? Does a liter of water contains about 3.35 times 10 to the 25 molecules? So liter contains this much. A certain river discharges about 2.2 times 10 to the 7th power liters of water every second. So every second, this river is discharging this much water. About how many molecules does the river discharge every minute? Write your answer in scientific notation. Let's look what else. The directions say use scientific notation. Use the multiplication symbol in the math palette as needed. That's this X here. No big deal. It says, well, round to the nearest hundredth. Notice the one before it said do not round. This one is telling us to round, so we have to be careful here, okay? Very, very careful. Now, I see that this is going to be an important part here. And then we also have, this is the important part, but this here says the river discharges water at about this amount, many liters per second. Are they wanting us to find the amount of volume every second, or are they wanting us to find the volume every minute? So how many seconds are in a minute? We need to make these units the same. So this is kind of like that first algebra nation problem that we did. Notice how this is a more complex problem. We don't have the same units, so we need to make sure we're putting it in units. How many seconds are in a minute? Well, hopefully we know it's 60. So the first thing we have to do is multiply. We have to distribute a 60 to this particular piece, right? So it's time to break that calculator out again. So we have to do 60 times 2.2. And we're going to get 100. So this really is 132 times 10. Remember, that's our base, times 10 to the 7th power. Now, we should be saying, hey, look, I know, I can see right here that this is not in proper scientific notation. I have more than just the ones placed to the left of this decimal. So I'm going to have to move this decimal point 1, 2 places to the right. If I move, I'm sorry, to the left. If I move to the left, that means my exponents are going to go up. So I went to the left 2. The exponent has to increase by 2. So 1 will be 1.32 times 10 to the 7, 8, 9, 9th power. Okay, so we have this done. Now, if we know that these many liters of water have passed in 1 minute, and we know that this many molecules are in a liter, we need to multiply these two together. So we can do that over here. You have 3.35 times 10 to the 25th power. I'm going to put them in parentheses. And then we have 1.32 times 10 to the 9th power. All right. So now, let's remember, this is the base. This is the base. When we had to multiply exponents together, it said the coefficients, we just multiply. So these are our coefficients, 3.35 and 1.32. Multiply your coefficients together. The base will stay the same, and we add the exponents. So here we go. We have to multiply. And we're dealing with 3.35 times 1.32 equals, that's 44.2. But remember, what did our direction say? It says round to the nearest hundredth. So hundredth is 2 decimal spots. Does this 2 say raise this 2 up or leave it alone? Yeah, that's right. We leave it alone. So 5 and above, you give it a shove. 4 and below, leave it alone. If your teachers taught you any of those weird little tricks. So let's write this. So this is going to here equal 4.42. The base is times 10. And the rule is we have to add these exponents. So we have 25 plus 9. 25 plus 9 is 34. Now, do we need to do anything to this exponent? We only have one decimal place to the left, so we're only in the 1 spot. We don't have to do anything. This would be your final answer right here. Okay? And you're done. I know this seems daunting and complex, but it's really, really, really not as bad as it seems. We deal with the coefficients. The base is the 10x. And then we have adding the coefficients. Okay? And that's it. The next one, thankfully, we're leaving the word problems, and it's just pretty straightforward. Okay? It wants us to simplify the expression by writing the answer in scientific notation. So we have to multiply our coefficients. So you have 0.1 times 2 is 0.2. So 0.2. Our base is the times 10. And all we have to do is add our exponents, because the rule says the base stays the same, add the exponents. Well, a positive 5 minus 9 is a negative 4. Now, I know some of you might say, hey, we have a rule for negative exponents. Not when it comes to scientific notation. We leave it alone. Because the scientific notation is basically telling us that if we wanted to write this number out, we would then move this decimal spot 4 places to the left. So the negative in this case is important for us to know. We need to leave it there for this. However, we're not done yet. Look at this number, 0.2. Remember I said for scientific notation, the number to the left of the decimal spot, we're only dealing with, it has to be 1 to 9, bigger than 1, but 9 or below, okay? Notice it's a 0, so this does not work for us. We have to move this decimal spot one place, this time to the right. So if we look at the Mr. Scientific Notation man, when we move our decimal point to the right one, we have to decrease the exponent. So if we made one move to the right, we subtract it by 1. Now we can rewrite the final time. We have 2 times 10, and -4 minus 1 is a -5. And then that would be it. We're good to go there. Okay. So basically this number here, we'd have to go 1, 2, 3, 4, 5. So it's 0.00002. We don't want to deal with that. That's why we have scientific notation. We are sitting here basically being able to rewrite this big, big, long decimal into something that's easier to work with. Number 4, notice what's changing. Now we have something inside of a set of parentheses raised to a power, and then that's being raised to a power. So again, this is our power to power rule. We're officially coming into that 7.3 section. And now we're looking at this as we have to say, okay, so what do we do here? Well, we have a coefficient of 9 being raised to the power of 2. We have a base and an exponent being raised to the power of 2. Let's break it up. We have 9 raised to the power of 2. And then we have the base 10 being raised to the power of 2. So the rule was base stays the same, multiply. So we have, what, 6 times 2. Now all we have to do is simplify this and see what happens. So 9 squared. 9 times 9, 81. And then we have times 10. 2 times 6 is 12. Is this proper scientific notation? This is 81. This is definitely bigger than 9, right? So we need to take where our decimal point is and move it one space to the left. And if we move to the left, we have to increase this by 1. Because that's what Mr. Scientific Notation man says. If we move to the left, we have to go up. So for every spot we move to the left, we go up 1. We moved it once, we add 1 to the exponent. So again, simplify 8.1 times 10 to the 13th power. And that is the final answer for raising a power to a scientific notation. Again, we have another one here. So we're going to take, what, 7 raised to the power of 2, base 10, 6 times 2. Well, 7 times 7 is 49. The base 10 is the base, so that does not change. 6 times 2 is 12. Again, this is not proper scientific notation. We have to move that decimal spot one spot, which means we have to add 1. So it's 4.9 times 10 to the 13th power. It's not so bad, right? Getting the hang of it. I want you guys to try number 6. Let's see if you can figure out number 6 on your own, okay? Try it and pause the video. We'll be back in just a second to see if you get it right. Did everybody get it? I hope so. All right, again, we have the coefficient is 3 being raised to the power of 3. And then the base is x10 or times 10. And that is 4 times 3. So 3 times 3, or 3 to the 3rd power is 3 times 3 times 3. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 equals 27 is the new coefficient. I can already tell you this is not in proper scientific notation. It's bigger than 1. Can't have that. Bigger than the ones place. We can't exceed 9, and we most certainly did. So because of that, we have to move this decimal spot 1 spot to the left. Left means we add. So 2.7 times 10 to the 13th power. And this is the final answer here. I know, guys, it seems a little weird. This is not something we do a whole lot of. We just may have 1 or 2 problems like it, and it's not hard, so we don't want to miss them. But if we don't, it's not like, the end of the world, okay? The last one, of course, we're going to have to deal with negatives, what happens to it. So we have it pretty simple. Again, our coefficient is 4 being raised to the power of 2. 4 being raised to the power of 2. The base is 10x. And this is what? Negative 4 as the exponent. Power to power rule says multiply the 2 together. Okay. Well, 4 raised to the power of 2. 4 squared. 4 times 4. 16. The base is times 10. And negative 4 times a positive 2 is a negative 8. All right. Look, 16, that not scientific notation. It's greater than 9. So we have to move the decimal spot 1 point to the left. If we move it to the left, then we have to go up. So again, remember, we have scientific notation, man. If you move to the left, it goes up every unit. Move to the left 1, it's going to go up 1 unit. And negative 8 plus 1 is a negative 7. Sure, my mouse is getting all messed up here. So 1.6 times 10 to the negative 7 power. And that would finish up this lesson for us today, guys. We've learned how to add, how to multiply. And guess what? Look, on the bottom of this, I've got all my exponents. So hopefully we did it all right. You go through and check it all. 2 times 10 to the negative 5 power. Yeah. So again, we're looking at it, guys, in 7 questions. Your homework is going to be identical to this. It is a worksheet. It will be uploaded. The only difference is the numbers will be different. So every single problem is done exactly like we did here. If you have your worksheet, you should be able to follow along step by step with these notes and be able to successfully replicate the pattern that we're doing. In math, it's just about learning how to understand the rules and replicate a pattern. It never changes. And then we add little crazy things like, Mr. Scientific Notation Man that helps us remember certain aspects, like when we move the decimal, depending on which direction, are we increasing or decreasing that exponent? Right, get out there, do your homework. I know this is a little weird. This is the one where we're probably going to have a lot of questions, and it's totally okay. Don't sit here and struggle on it. Ask questions. Have a great one, guys.